We're pretty good at finding horizontal and vertical asymptotes just using our algebra skills. But now what we want to do is to go a bit further, and we want to show these asymptotes using limits. Let's just real quickly look at the graph of our f of x here, and we can see the vertical asymptote at x equals -5 and a vertical asymptote at x equals +5. And then we can also see the horizontal asymptote, which is our end behavior. What I mean by that is as x gets larger and larger, and we're going to say let x go to infinity, what does our y get to? Well, our y is approaching 0. And likewise, as x approaches negative infinity or goes to the left-hand side farther and farther, our y value is once again approaching 0. So that would be our horizontal asymptote, y equals 0. And now we're going to go ahead and look at this using the limits. First thing I want to do is I want to factor that denominator. Now this function is already reduced, so there's not a common factor between the numerator and denominator, so I don't need to do anything with that. But to find those vertical asymptotes, I'm going to look at the x values that make this denominator go to 0. And that would be the x values of plus or minus 5. If I put that on a number line, I get our -5 over here and our +5 over there. And now what I'm going to do is I'm going to go ahead and I'm going to look at this limit as x approaches -5. But what I want to do is I want to look at that limit as I'm approaching it from the left-hand side. So if we come over to this graph that we have, I'm going to come at -5 from this left-hand side. I'm expecting to find that limit of f of x as x approaches -5 from the left-hand side to be negative infinity. As you can see, our y value is going down the closer we get to -5 from that left-hand side. So once again, this is what I expect to find. Let's go ahead and let's show that. If I plug in -5, and I'm just on the left-hand side, and I square it, and then I subtract 25. I want to really look close at that denominator. If I'm on the left-hand side of -5, so I'm over here, I've got to think. On that left-hand side, plug in some numbers. What would that look like? It would look like maybe -5.1 or -5.01, so on and so forth. Getting closer and closer to -5, but I'm just on the left-hand side. If I take those kinds of numbers and I square them, I want to look at those in relation to this 25. I want to compare these. And if I take that -5.1, for instance, or a -5.01, and I square it, I'm going to be just bigger than that 25. So what's going to happen here is this denominator is indeed going to go to 0, but we're going to be just positive, just to that right-hand side of 0. Because that first term, that -5 on the left-hand side of -5 squared, is going to be just bigger than that 25. So we're going to have a positive number in that denominator that's going to be awfully close to 0. And then in the numerator, of course, we just have our -5. Well, if I have a negative number divided by a positive number, my answer is going to be negative. And then I have to think, if I have -5 and I'm dividing it by a really, really small number, how many times is that small number going to go into -5? Well, it's going to go into it a lot of times. In fact, we're going to start approaching what we call infinity. So that limit from the left-hand side of -5 is going to be negative infinity, which is what we assumed would happen based on the graph. Next, I'm going to look at as x approaches -5, but I'm going to come from it from the other side. I'm going to come from it from the right-hand side. Now let's go over and let's look at this graph. As my x values come at -5 from this right-hand side, then what's happening to my y values? They're getting bigger and bigger. So I would anticipate that my limit should equal positive infinity in this case. And we're going to follow the same kind of logic that we did in the previous. I'm going to have -5, but I'm going to be just on the right-hand side of -5. So once again, coming up here to my number line, I'm going to be on this side, the right-hand side of -5. I'm going to think about the values that that's going to be. In my mind, I'm going to think -4.9 or -4.99, so on and so forth as I get closer and closer to -5, but I'm just on the right-hand side of that. If I take those kinds of numbers and I square it, this should be a square, then what is that first term in the denominator going to be compared with 25? So if I take -4.9 or -4.99 and I square it, I'm going to be just smaller than 25. So when I take that number and I subtract 25, I'm going to end up being very close to 0 in my denominator, but I'm going to be just smaller or just to the left-hand side of 0. So I'm going to be negative. And then if I have -5 in the numerator, I have a negative number divided by a negative number. I'm going to get a positive. In this case, I have a really, really small number being divided into -5. How many times is that going to go in? Well, it's going to go in a lot of times. So this is going to be positive infinity, which is once again what we thought we would find just based on the graph. Next thing I'm going to do is I'm going to take the limit as x approaches positive 5. I'm going to be on the left-hand side of positive 5. So I'm going to be over here somewhere. I'm going to take that and I'm going to look at the graph and I'm going to see what I would anticipate. As I'm coming at positive 5 from that left-hand side, my y values are going down. So I would anticipate this to be negative infinity. If I plug in 5 in that numerator and then I have 5, but just to the left-hand side of 5, I square it, I subtract 25, that's my denominator. Then I'm going to think to myself, what kind of numbers am I looking at? Just to the left-hand side of 5, I'm going to be perhaps 4.9 or 4.99. I'm going to keep approaching 5. I'm going to get closer and closer, but I'm going to always be just a little bit to that left-hand side. So when I square those kinds of numbers and I compare it to 25, what I'm finding is I'm going to be just smaller than 25. I'm going to have 5 in the numerator, but in the denominator, I'm going to be approaching 0, but I'm going to be just negative. I'm going to be just smaller than 0, which would give me that limit of negative infinity. Lastly, I'm going to look at the limit as x approaches 5, but I'm going to be on the right-hand side. So coming over my number line, I'm over here. Looking at the graph, I'm going to be coming at positive 5 from the right-hand side. So what happens to my y values? They're going to go up. I would anticipate that I should find a limit of f of x as x approaches 5 from that right-hand side to be positive infinity. Well, let's plug it in and let's see what I get. I get 5 on that right-hand side. I square it, I subtract 25. Well, what numbers are just to that right-hand side of 5? Maybe 5.1, maybe 5.01, so on and so forth. So this first term right here, when I compare it to 25, this first term is going to be just a little bit bigger than 25. So yeah, I'm going to approach 0, but I'm going to be just a little bit bigger than 0, which is going to give me a limit of positive infinity. So those are my vertical asymptotes that I've shown. By definition, if the limit of your function goes to positive or negative infinity when x approaches a certain value, then you have a vertical asymptote. So we've just shown that. Now let's go ahead and real quick, we're going to look at that horizontal asymptote. Now, horizontal asymptotes is all about that end behavior. That's the limit as x approaches a positive or negative infinity. What number does your function approach? So let's look at the limit as x approaches positive infinity. Now, go back to that original function, the f of x equals x over x squared minus 25. As x is a really big number, let's look at that denominator, specifically the minus 25. If I take a really big number, say 1,000,000, and I square it, I'm going to get a really, really big number. I'm going to get a lot of zeros. And so when I subtract 25, you're not even going to notice that 25 is being subtracted from it. Minus 25 is just not going to matter anymore. It's not going to affect the function anymore. We can say that the limit as x approaches infinity of f of x is going to equal the limit as x approaches infinity of x over x squared. We're just going to leave off that minus 25 because once again, as x gets really big, it just doesn't matter anymore. Those limits are going to be the same. So I'm going to reduce this. I'm going to say, okay, well, x divided by x squared is the same thing as 1 over x. Well, if I put a really large number in a denominator like that, 1 over 1 billion, what number am I approaching? I'm getting really, really, really small. I'm going to approach 0. So that's my end behavior. As x approaches infinity, my y value is going to approach 0. We're going to use that same logic as x approaches negative infinity. Once again, if I put a really large in magnitude number, but negative, into that denominator, so I plug it in, I get that really big number that's negative, I square it, I'm going to end up with a really, really large but positive number in this case. So once again, this limit as x approaches negative infinity of f of x is going to be the same limit as x approaches negative infinity of x divided by x squared. That minus 25, we're just going to drop off. It doesn't even matter anymore. When you're looking at end behaviors, what you're going to do is you're going to take that numerator, you're just going to find the term that has the highest exponent. And that's the only one you're going to worry about. Same in the denominator. You take the denominator separately and you just look at the one term that has the highest exponent, and you're just going to keep that term. Everything else is going to get dwarfed by these huge numbers we're dealing with, and they aren't going to matter. So let's go ahead and reduce that. The limit as x approaches negative infinity of, this is going to reduce to 1 over x. If I plug in a negative infinity, a really big but negative number, I'm going to approach 0. 1 divided by negative 10 billion. It's going to be so small. We're going to approach 0, which is what our graph shows. So this would be our horizontal asymptote. We would have a horizontal asymptote at y equals 0, and we've shown that using limits.